Day 3 in geometry. It's Thursday, May 29th. It's basically like your Friday. There's no classes tomorrow. There are never classes on Fridays, guys. Just a reminder of that. And today, for our do now, I gave you 4 sets of angles where you are using the relationship between the angles and you're solving for x by setting up equations. Let's look at number 1 to start, and let's wrap up our side conversations. You're okay. Number 1, whenever we look at this angle, we see that there are 2 small angles and then 1 large angle. What is the measure of that large angle? 90 degrees. How do you know it's 90?
Point straight up.
Pointing straight up. This is pointing straight up right here. How else can we tell it's 90 degrees? It's got that box, that red box. This tells us that it is a 90-degree angle. So, when we are setting up our equation, remember, we talked about the angle addition postulate. That's a fancy word for when we have 2 angles inside of a big angle, we can add them together, and they're equal to that big angle. So, these 2 little angles are equal to the big angle that is 90 degrees. So what equation could I write to solve for x here?
X plus 3
X plus 3
plus 7
plus 70. Good. We're just adding this value plus that value. And then what?
equal to 90.
Equals 90. Perfect. So this is the equation we would want to start with. X plus 3 plus 70 equals 90. And once I've set my equation up, what is the first thing I want to look at and start doing?
Add
Add 3 and that 70. We're going to combine our like terms.
That's what threw me off.
So 3 plus 70, what will that give us?
X plus 73.
Yes, x plus 73
Equals 90.
equals 90.
Now you take 73 from 73 and 73 from 90.
Good. We're just going to take 73 away from both sides.
So it's going to be X equals 17.
X, bring that down, equals 90 minus 73 is 17. So for number 1, X is 17. Any questions about number 1?
You need to put your degree sign.
Ooh, that's a great question. On this problem, do I need a degree sign?
Yep.
No, it's part of the equation.
You could put a degree sign, but in this one you may not necessarily have to because the x is just the missing value here plus 3. That doesn't say that this angle is not 17 degrees. X is just 17.
So it wouldn't be wrong if we did.
It would not be wrong. I won't count it wrong if you don't put the degrees there.
Okay.
I won't count it wrong if you do put the degrees there. Technically, you could put that there because it's really 17 degrees plus 3 degrees. If I wanted to go a step further, this is like a bonus question. What is the measure of this angle?
20.
Almost.
17.
17. Oh, yeah, no, it would be 20. I'm wrong. Sorry. 17, 18, 19, 20. It's 20 degrees, Steve. You're right. You're correct. Yes, because what we just did is we replaced the x with 17, and 17 plus 3 is 20. So just a little bonus thing you can do on there. I didn't ask for that, though, so if you didn't do that, that's okay. All right. Can we move on to number 2? Yes, no? Okay, just want to make sure everybody's done right now if they haven't yet. So, number 2, what is the measure of the big overall angle here?
180 degrees.
180 degrees. Now, I'm referring to this big angle. It's a half circle, basically. How do we know that this is 180 degrees?
Just a straight line.
Because it's a straight line. This is a straight angle. A straight angle is always 180 degrees. So, how am I going to set an equation up to solve for x here? X minus 10, get a different color. Perfect. So x minus 10 plus 130. Yes, equals 180. So we have our equation set up. We added together these two smaller angles and set them equal to our big angle.
That'll be x equals 120. Well, x plus 120.
Ooh, yes. So what you just did there, you just combined these like terms. We have minus 10 plus 130. We add those together, we get 120
Equals 180.
So x plus 120 equals 180. Did anybody get x plus 140?
Yeah, like 140. I did.
Why is it 120 and not
It's
140?
negative 10.
It's minus 10. Yeah, it's negative 10. Yeah, we have to pay attention to signs all the way back to like pre-algebra. I tell my pre-algebra students this right now who are struggling to learn about their positives and negatives. Everybody struggles with that. Negatives are confusing for no reason. If you see the minus sign, we're taking away, we're not adding. Super simple mistake to make. It happens.
90,
So now what?
90 minus 120 from both sides.
Yeah, we'll just subtract 120 from both sides.
And cancel, so x equals 160. What? X equals 60.
60. Good. X equals 60. Perfect.
15 plus 15 negative. Wait a minute, 60 minus 10.
Yes.
Comes to 15.
Perfect. So, Jean, thank you. If we wanted to solve for this missing angle, we solved for x. We would just do 60 minus 10. This missing angle is 50 degrees. Again, I didn't ask you for that, but if we wanted to take it a step further, that's how we would do it. Kind of cool.
I didn't know.
So, you
180 degrees.
Yeah.
So that's a great question. I want to repeat this question because I bet a few of you are thinking the same thing. How do we know that this is 180 degrees? How do we know? Can anybody answer that? Because it's a straight line. This line is called a straight angle. Anytime that we have a line, it's 180 degrees.
Yeah.
We can also see this on our protractors.
Yeah. I was just about to say
If
that.
we started from 0 and go all the way open to the other side, I know the biggest number they put on here is 170, but if you go 10 more, it's 180. It would be a straight line for 180 degrees. So that is exactly how, if you have a straight line, it will always be 180 degrees. Yes.
I don't know how to say this. So on these, because the way I did it wrong. I put x minus 10 equals 130 degrees. How do you know on all of these, do you have to always,
Combine your life.
Like add them together and equal to the big angle?
like the 180 degree part, is that always gonna be like that? Like, just like on the first one, the 90 degrees?
Yes. Yes. So if we are, if you're setting two values equal to each other, like you did 130 equals x minus 10, or maybe flip flop that, we would only ever set two things equal if we know that they are the same. And in this case, we can even just see by the picture, these are not the same size. So we can't set them equal to each other. We're kind of using this as a picture because if we think this little angle plus this slightly bigger angle, when we put them together, they make that big 180 degree angle. So let me draw a picture on another page to show this a little better. I think that might help. without all the numbers. So here is my 180-degree angle, and I'm going to draw the big arc. It's a half circle. What I'm saying here with this problem, and I'm going to pull these out, is that this plus that equals that. See that? Does that visual help a little bit?
That makes sense.
Good, good. Yeah, sometimes drawing the arcs helps too. Just so you can picture it as more of a shape rather than these random angle bends and, so drawing those arcs can help. I think, it starts to click just the more that we do it and we start to recognize the relationships. I just taught you yesterday. This is new stuff. You guys are doing great. Did anybody else do that same thing where you just set the angles equal to each other?
Yeah, and then if you just
Yeah.
add 130 and 50, you're gonna get 180 anyways.
Right. And that's another thing. Thank you for pointing that out. This 130 degrees plus the 50 degrees, that equals 180. So our answer makes sense. It makes sense. Kind of cool. That's why what I do like about geometry is that rather than hoping your answer makes sense, you can look at the picture and say, I can see where that makes sense actually, because it like fits together like a puzzle. I think it's kind of cool. Okay, do we have any other questions about 1 or 2? Either one. Let's go ahead and look at number 3 then. Zoom in on that. So for number 3, let's think about how we would set this equation up. What is our big angle?
38. Oh, the big
Forts.
70.
70.
70 is what these two angles add up to. That's what it's going to be equal to. So since I have 38 degrees and then 5x degrees, and they add up to 70, what equation am I going to write?
5x
Mm-hmm.
plus 8.
Yes.
Equals 70.
Yes. 5x, this one, plus the 38 is equal to this big angle, 70 degrees. So here is our equation. 5x plus 38 equals 70.
You subtract 38 from both sides.
Yes, subtract 38 from both sides.
Which one we even with 5x equals 32.
5x equals 32.
Then you divide 5.
Yes, divide by 5 on both sides. And what do we get for x?
6.4.
X equals 6.4.
Is it okay if I did subtraction instead of addition? I did 70 minus 38 equals 5x. I got the same answer.
Yes,
but okay.
yes, that works too. You can absolutely do it that way. Absolutely. Okay, so our answer for number 3 is 6.4. Yes, it's a decimal. Decimals are okay. I think they make everybody a little uncomfortable, but decimals exist. Okay, so if I wanted to take this a step further, what's the measure of my missing angle here? How would I find that?
5 times 6.4.
Yes, 5x means 5 times x. My x is 6.4. So what is this angle?
32.
32. 32 degrees. Nice. Again, I didn't ask for that, but we can do it, so why not? Okay, any questions on number 3?
Breaking them equations down, that's what gets tricky.
Yes, that can be one of the hardest parts is getting the equations down for sure. Where the algebra comes in and
What if you did a different thing?
What'd you do different?
Well, I mean, I did both, like adding and subtracting.
Did you write like a different equation?
Like I put, on the first one, I did that one, what we just did.
Mm-hmm.
And then the second one, because I was questioning myself.
This second one?
No, still on number 3.
Okay.
I put 5x, take away 38
Mm-hmm.
equals 70, and then I added 38.
And that would give you a different answer. Right.
Because I was questioning, like I didn't know.
Understandable. So if we did 5x minus 38, I bet you got a, did you get a negative answer?
I got 21.6.
Okay, I gotcha. So if we got an answer of 21.6, you can also use plugging that back in to check your answer. So this is how I could check it. Let me see. So if I did 5 and then I plugged in 5 times 21.6, I'm gonna get like over 100 degrees for this angle. And we could look at the picture and say, does that make sense? Is this more than 100 degrees? No, it can't be because it's smaller than 38. So that's always a good way to check your answer and see if like does this number even make sense with what I just did? And if it doesn't, then we can go back and say, okay, what did I not do correctly? Because what we're doing here is we are adding these values together. The 5x plus the 38.
I was just like not for sure.
Right.
So I just did both.
I get you. Does it make sense why we're adding though instead of subtracting now?
Yeah.
Good. I appreciate you asking that. Do we have any other comments, questions about this one or any previous ones? Hey, let's go to number 4 then. This one is actually the simplest one of them all. Believe it or not. Because I didn't put anything with the x, it's just x by itself. What equation will I use? 90 is my big angle. 90. And really, yeah, you're just going to subtract 79.
That's
Yeah.
all I did.
And the reason that we're subtracting 79 is because the equation would be what? X plus 79. Good, equals 90. And when we solve this, we end up subtracting 79
Yeah, both sides.
from both sides.
11, x equals 11.
Yes. So x equals 11 degrees. This time x is our measure. 11 degrees. Okay. All right. Is that too bad? Is that like really, really difficult? Or is it feeling slightly easier after running through a few?
Now that I know that decimals are allowed, it's better.
Yes, decimals are allowed. Absolutely.
You
You can turn it in whenever. I got number 4 wrong. What'd you get for number 4?
169.
Did you
I
subtract?
I added both of those 79 plus 90. So I looked at it on yours.
Gotcha. Okay. As long as you can, see it and say, okay, actually, it makes sense why you did it this way. It makes sense to you.
I would say I need more.
Need more practice. Okay. Let's do a few more like this. Make sure that it's really good in our brains. And we're actually going to end up getting to do more practice in the next thing that I'm showing you today. So it kind of ties in. It all ties in. Okay. So what I would like you to do right now is we're going to take a little breather from this specific thing. And I want to give you a few notes. And after the notes, we're going to do a bunch of practice. And the goal is to get you guys out a little early today, give you time to get caught up on things if need be. Yeah, that's the plan. So I'm gonna go ahead and pause this recording while I get my notes out. I'll let you guys get your notes out, whatever you need to get started. Okay, so I'm gonna go ahead and title my page. Geometry. And these are day 3 notes.
Oh.
Data here. 5/29, May 29th.
All right. And then.
What is it, charge?
And then once we've got our notes out and ready, we are going to title this line and angle relationships. We're going to talk about how when certain lines form certain angles, we know certain things about them, and that'll make sense in a minute. So we are first going to talk about parallel lines. Parallel, parallel lines. And the symbol we use to show that lines are parallel looks like this. 2 lines beside each other like that. Have any of you ever heard the word parallel?
Yep.
I bet a lot of you have. Do any of you know what parallel lines are, what that means?
2 lines that run along together and have a cross.
Yes. 2 lines that run side by side that never touch each other. They always go in that same direction. They never cross paths. So I'm going to write a little definition here. Okay. Lines that side by side and never cross. An example of parallel lines, I will draw 2 lines. And what I'm going to do is I'm going to draw one of my lines using the top of my ruler. I'm going to keep my ruler there, draw another line under the ruler. That way they are going at the exact same direction. You will know that 2 lines are parallel because the lines will have markings on them. If you have 2 lines like this and they don't have this marking, we can assume they're not parallel. This is the marking we'll see. It'll be like a little arrow. on both of the lines going the same way. Sometimes it'll even look like a triangle. This means that the lines are parallel and never cross each other. They go on forever and never touch. I wish I wouldn't drawn those so far away. Kind of a waste of space. We've got that. The next line and angle relationship we're going to start talking about is perpendicular lines. And the symbol for perpendicular looks like this, like an upside down T. Have any of you heard the word perpendicular?
Two lines
Yeah?
across.
They do cross. Does anybody know the angle that perpendicular lines cross at? Or is this going to be new for all of us?
I'm gonna get
So
some.
they cross like that.
They cross just like that.
And it, 40?
Not 40.
90.
90.
Yeah,
It's going to be two lines that intersect
at a 90-degree
and
angle.
it creates a 90-degree angle at all four angles. 4 90-degree angles. So, lines that cross and form a 90-degree angle. So that might look something like this. Draw one line going right up and down. Another one going straight across left to right. You'll know that they are perpendicular because they're always going to have that 90-degree angle box. In just a moment, we're going to get into why there only has to be one box. And that one box tells us that all four of these angles are 90 degrees. We actually don't need a box in all four of the angles. I'll show you why in a minute here. So I'll give everybody a second to write that down. I just gave you a couple of things to write. That's fine. So we have parallel lines, we have perpendicular lines. And now we're going to talk about something called, can I move this first? I'll keep it right here. Okay. Now we're going to talk about a transversal. Transversal doesn't have a symbol that I know of. So we're just going to write the word transversal. And a transversal is just a line that crosses through parallel lines. And I'll draw a picture of that next too. parallel symbol. Okay, this means parallel. It's a line that crosses through a set of parallel lines. So, draw some parallel lines again. Anytime you draw parallel lines, don't forget to add arrows inside both of those lines because that shows they are parallel. And the transversal is going to be a line that goes through these. So I'm just going to draw with green, the same color I wrote my definition or my word in, like that. That's a transversal. It is a line that crosses through both of these lines that are parallel to each other. So I just want to give you those 3 new vocabulary words. And once we've got that down, we're going to go to the next page and draw kind of a big version of this picture. And we're going to talk about some things and how we can use them. This.
Change it.
Okay, so let's go to the next page. For me, I don't know if it's the next page for you. And I'm just going to title my page again so I don't lose it later.
It'll be negative. Make sure you know it.
No. And page. Now on this page, I am going to draw. Okay. I'm gonna have us draw a larger version of that last picture we just drew. I'm gonna give us some space so that we can label things. So I'm going a little bit down the page for my first line. That. I'm gonna leave some space in between to draw the line that will be parallel to this one. And then once more, we want to put a transversal going through those parallel lines. Gonna forget to mark that these are parallel. Now, whenever we have 2 parallel lines and a transversal, we have some relationships between all of the angles that will always be true. I'm going to start with this top angle at the left here, and I'm going to draw an arc, one arc here. And we'll call this angle A. Now, if I look at angle A and I go directly across, kind of diagonally, what do you think I can say about the relationship between angle A and we'll call this B?
Equal.
They're equal to each other. Yes. When we have a transversal, or honestly, any two angles that are right across from each other, just like this, they will always be equal to each other. These are called vertical angles. Vertical angles. So I am going to write here, let's see, underneath, I'm going to write vertical angles. They're equal to each other. So underneath here, I'm going to say angle A is equal to angle B because they are vertical. They're right across from each other. Okay. We could also look at the bigger angles. So I'll use a different color. Now, instead of one arc, I'm going to use two because whenever I label angles with the same amount of arcs, it means that they are the same. So because A and B are the same, I only put one arc. We'll call this C. Call the other angle vertical to it D. These angles are also equal. They're vertical angles. So angle C equals angle B. I really should have put those lines a little further away from each other. Might have to draw another one. Let's see. That or I should have just made my letters smaller. That was kind of silly of me. I'm gonna make one more line. I'm sorry, guys. This messes up your notes. I'm gonna get rid of that line with some white out. Too close together. Good enough for now. Okay. Let's call these four angles as well. Let's put these, give them some names. Let's call this one E and then F. Those are also vertical angles because they're across from each other. Angle E is equal to angle F. And then we'll do a G and an H. G, apologize for my artistry. It's not very good. Now we've named all of our vertical angles, but now that we're looking at the full picture, we have 8 different angles that are labeled here. Do we notice any other angles that I didn't list that might also be equal to each other?
B and G.
Ah.
Oh, wait, no, wrong.
A, B,
C and G.
C and G, yes.
Okay.
D, and H,
D and H should be equal. A and E,
B, and F.
B and F. What you just described there are called corresponding angles. So that's another relationship we're going to talk about. Let me write that down next. Corresponding angles. So corresponding angles, these are the ones that are in the same position.
Opposite.
Yes, but on the other parallel line. So you can see that angle C is in the same spot as angle G, just higher up. Angle F is in the same spot as angle B, just lower. It's the same angles, just in a different spot. And that's because these lines are parallel. So when this transversal goes through it, it's going through at the same angle, since these are going at the same angle, the lines that are parallel. So let's name all of our corresponding angles. We'll start with A.
A,
E is the corresponding angle. So angle A is equal to angle E. What about angle B? What's its corresponding? F. Good. Angle B corresponds with angle F. What about angle C?
G,
G is the corresponding angle. And last but not least,
H, and D.
H and D are corresponding. Good. Perfect. So we're learning about the vertical angles and the corresponding angles here. Now, I wonder if I can ask you a slightly tricky question here. Angle A and angle C. Would you be able to tell me what angle A and angle C
180.
add up to? 180. How do you know that?
Add them together.
We're adding them together, and why do they add to 180?
With the straight line.
Because they make a straight line. So any of the angles that are right next to each other are always going to add up to 180. A plus C is 180. What about C plus B? That's a straight line.
Yeah.
B plus D, 180. D plus A, 180, straight line. E and G, G and F, F and H, H and E. Kind of cool, kind of cool. So any of the angles that are side by side add up to 180 degrees. So we could make a note of that as well if we wanted to. Let's see. I'm going to say angles that are side by side. You zoom in on that a little. Okay. And form a straight line. To 180 degrees. Lots of drawing today. And I'm going to zoom out a little bit, leave this up in case anyone is still copying. And I'm going to pass out a little worksheet that I would like to go through a few problems with you together. Back from our break. So let's look at a few examples together on this worksheet. Let's think about what's going on. So, number one, I have two angles that I'm looking at. This angle that is 8x plus 4, and the other angle is 8 plus 16x. How are these angles related to each other? Are they equal to each other? No. Do they add up to something? They add up to 180 degrees. So I know that the blue angle plus the purple angle equals 180 degrees. And here's a good way to look at it. I'll call this angle A, and then I'll call this one angle B. And if I wanted to write an equation without putting all the complex numbers in first, this part is kind of optional, but sometimes it helps simplify it. I could say that A plus B equals 180. Why do these angles add up to 180 degrees?
Straight lines.
Because they form a straight line. Perfect. They form a straight line, so they add up to 180. So now that I know I'm going to add them together to make 180, what should I replace the A and the B with to make my actual equation? Yes, 8 plus 16x, that's my A value. So I'm just going to copy that down. 8 plus 16x, that's A, plus, what's B?
8x
Aha, 8x plus 4 equals 180. Okay, so now we have a big equation written out. Just like we did whenever we added angles together to solve, or whenever we did the segment addition postulate, what is the first step we always need to take?
Combine like terms.
Combine like terms. So let's see. I'm going to just start from left to right. I'll start with 8. Do I have any like terms that I can combine with 8? 4. Okay, so I'm going to put those together. What's 8 plus 4? 12. 8, 9, 10, 11, 12. Yes, 12. Okay, and then next I have 16. Perfect. 16x and 8x. What happens when I put those together? 24x. So now I have 12 plus 24x equals 180. Now we can solve this.
That's why I keep messing up.
All right, so what should I do next?
You're going to take away 12.
Yes, take away 12 from both sides, minus 12.
Plus cancel.
Yes, 12's cancel.
So you got 24x equals
160.
26.
180 minus 12, what is that?
168.
168.
168.
Now
And
you divide 24x on both sides.
yes, we're going to divide by 24 so that those cancel. Do it on both
And x
sides.
equals 7.
And x equals 168 divided by 24, that's 7.
That'd be 7 degrees.
Or just 7? You could just put 7, since neither of these are 7 degrees, we're just solving for that number that is x, the x value.
Okay, just
So you can
making
just
sure.
keep it 7. No, good question. Okay, so there's number 1. Very nice. Any questions about what we just did before we try another? Okay. And I'm gonna this. Can we try number 2? Okay, I'll wait a second. Got a few people still looking. Pause that for a minute. This will be a different one. Number 2. Now I have 2 angles in different positions again. I'll call my 100-degree angle A. And we can call x plus 109, we'll call that angle B. Now, we didn't specifically talk about how these angles could be related to each other, but we can always use that chart that we drew in our notes to help us decide. Let's see. I have one that's on the right on the inside, one that's on the left on the inside. That would be like B and E, right? How are those related to each other? Let's see, they're not technically corresponding. I didn't teach you this word. There's so many words that I could use to describe. Technically, they're called alternate interior angles. We could get into all the fanciness. We're just gonna say these are equal to each other. They are. Okay. They're equal to each other. So we can set these equal to each other, can't we?
Mhm.
Okay, so instead of adding things together, I can say in this case, A is equal to B. So what am I going to replace A with? 100 equals,
109.
not 109, there's one thing missing. X plus 109, good. X plus 109. Perfect. How will I solve for X? Subtract. We're going to subtract 109. Both sides.
Yeah, X
Minus
is
nine.
-9.
Yes.
Minus
X
nine.
is -9. Now, does that make sense? Can we have a negative number?
Nope, you gotta flip it.
Do we? This is a trick question, actually. Well, not really. It's not a trick question. It's a question to consider. Am I saying that this angle is -9 degrees? No. I'm saying that X, the value of X is -9. So guess what? -9 instead of X plus 109. What does that equal? 100. And if A is equal to B, then B should be 100 degrees. So that makes sense. X is -9 because this angle has to be 100 degrees. So that's our answer for number 2. -9. You can get a negative. You won't have a negative angle, but X can be negative. Okay. Can we try number 3? Okay. Anytime that I move to the next one, if you are still writing, stop me. I'm not going to get annoyed with you. I want to make sure you have things written down that you need. Okay. Number 3. We'll call 11x plus 12 angle A. We'll call the 100-degree one angle B. How are these angles related to each other?
Parallel.
Not parallel. They're going through parallel lines. They're equal. Yes.
Yeah.
They're equal to each other. They're on the same side and they're corresponding. These are corresponding angles. They're both on the right side at the top of each line. You see that? And sometimes it helps to draw the arc Helps you visualize it better. So in this instance, A is equal to B.
So we go 11x plus 12.
Yeah, so we're gonna replace A with
11x plus 12
11x plus 12
equal
equals
100.
100.
You do a subtraction.
Yeah.
Let's move to
Subtract 12. Good.
Close cancel.
100 minus 12, what's that?
11x 88. 11x equals 88.
Good, so 88, bring down my equal, bring down 11x, and then what's my last step?
You divide 11 from each
Yes.
side.
Divide 11, both sides. And x equals 8. There we go. That. Questions about numbers for E?
you.
It can be confusing, it absolutely can be. But the reason I wanted to give you such a large packet for this one this time is because since there's so many different types of relationships, the more practice problems you do, the more it clicks in your brain, the more it starts to feel natural. Math is definitely something that you have to just do over and over and over and over until it just makes sense. Yes.
So I don't know if I'm gonna look forward to this right. Okay, so like you made the labels, the A and the B. Does it matter if we would do opposite, the A and B? Like,
No,
okay.
absolutely not. You don't have to do A and B. You also don't have to put it in this order.
That-
You
yeah,
can
that's what I was
say
thinking.
Yeah,
yes.
that's the way I do it.
You
I
can do
that.
100 equals 11x
Okay.
plus 12.
Okay.
Same answer. It'll work. Okay. Are we ready for number 4?
Yeah, we're
Okay. Let's look at 4. How are these angles related?
Correspondent.
Not corresponding. The other one, they are equal to each other. What's that relationship called when they're right across from each other?
Vertical.
Vertical. These are vertical angles, and vertical angles are equal. So,
basically like number 1.
what's the equation I would write?
23x subtracted from 5
23x minus 5
Equals 110.
equals 110. Okay. You guys try to solve that one on your own for a sec.
No.
Try to solve it.
That's already done with me.
You're funny. Solve it. And I'm going to solve it silently up here. Look up. Give me a thumbs up if your answer matches mine. Up if yours matches. That's so good.
I got 5.
Okay.
I know this is gonna probably be silly, but I'm struggling with grasping, like, knowing if it's A plus B or if it's equal.
Mhm.
That's what I'm sure.
Yes, and that's always the trickiest part. So as a rule of thumb, they are always going to be added together to equal 180 only if they make a straight line, only if they're right beside each other. Or you can also look at the shape. Like I can say, well, A looks like B. They're the same shape. They both are like the smaller or the bigger angle. So they're going to be equal. And number 1, you can tell these are not the same size. So they're gonna be added together. These, if you rotate it, these are the same size, so they're equal. These across from each other are the same size. They're both the big angles, so they'll be equal. And I think that is going to get easier to recognize just the more examples that we do. Because realistically, we've only done 4 problems out of all of these. And I just taught this to you like 10 minutes ago. So don't expect to be a genius at it the very first day that you learn it. It is so okay for it to feel a little hard at first. Because it is hard. This is not easy.
And you use the terminology, that's what I'm saying.
Right. It's new words. I'm speaking another language. Absolutely.
But it's really simple, for real, you just gotta pay attention to it.
Let's go to the next page. And how about this? Let's go through and without just solving them, let's decide for each number, are they going to add to 180 or am I setting them equal? Let's practice recognizing that. So for number 5, will I add these together and set them equal to 180 or will I put them equal to each other? Ooh, I hear both answers. Defend your answers. Why would I add these together? Do they form a straight line?
Yeah, they're on the same side, ain't they?
Let's see. We have this one here,
And they got.
and we have this one here.
You're subtracting.
Are these? These are equal.
Yeah.
These are equal. You can see, first of all, we're looking at when we have parallel lines on a transversal, you're going to have 4 angles on top, 4 angles on bottom. And it forms like 2 pies. Okay, like I'm going to draw this. There's a circle here, and there's going to be like cross sections. The top angle, 100, is right here. The bottom angle, x plus 108, is right here. These are in the same spot, aren't they? You see that? If they're in the same spot, they're equal. They're equal, okay? The only time they'll add up to 180 is if they're side by side or if they are very obviously different sizes. And we're going to see more of those as we go through. Let's practice recognizing that. So number 5, I'm going to write equal sign so that when we go back to it, we know we're setting them equal. And if you want, we could even write that corresponding. They're equal because they're corresponding. They're in the same spot on those pies. What about number 6?
Equal.
Those are equal. Why are these equal? Why are they equal?
Same side.
They're the same size.
Vertical.
And they're vertical angles. They're right. Anytime an angle is right across from another angle, they're the same. They're vertical. Number 6, we set them equal. They're vertical.
Yeah, we gotta note that down too.
Yeah. Okay, what about number 7? Are these going to be equal or do we add them up? Why are they equal?
They're corresponding.
They're corresponding. They're in the same spot on the other line. And they're the same size. They're equal. These are corresponding angles. Number 8, are these equal or do we add them to 180? Why? They're side by side and they form a straight line. Do we see that? Whenever we put them together, They make a half circle like that, and they make a straight line on the bottom. See that? These are gonna add to 180. So see, these are different sizes. This is kind of a smaller angle. This is a bigger angle. They're not the same size, so they can't be equal. Okay, let's look at number 9. You want. You would say add? What makes you say add? So there's these angles, let's see. In here we have 4 angles that look like this, the big ones. And then we're gonna have 4 small angles. Are these equal or are they not equal? These are actually equal. And this is another thing that we can do whenever we're looking at these charts like this. If we start with one angle, let me get a sticky note to write this. You could always go through and recreate this picture that we put in our notes. I can start with one angle and go from here. I'll say, well, the angle across is equal. So there's that. And then I know the corresponding one is equal, and the angle across is equal. Put those, just like we did here. And then I know all the other ones are equal, but differently equal. You know what I mean? They're the bigger ones. This is kind of that relationship that every single one of these questions will have. So number 9, the angles are equal. These two are equal. They're both the big angles instead of the little ones. 9 is setting them equal to each other. See, how about number 10?
Equal.
Equal. Why are they equal? They're the same size. And they are corresponding. Good. They're equal. They're the same size. And they're corresponding. How about number 11? They're equal. They're both the little angles. Those are equal. They're the same size. These are kind of vertical. This, I just because we have so little time, I don't want to make you guys memorize all the vocab. Technically, these are called alternate exterior angles. I'm not gonna make you remember that, but it is what it's called. They're equal because they're the same size. We're gonna go with that. We just can't memorize everything like that in 4 weeks. It's already, yeah, that's a lot. Okay, number 12. This one's tricky. Ooh, yes. Why do we add these together?
They're side by side and on a straight line.
They're side by side, they're forming a straight line. The other thing we can do, if you're not sure, go ahead and see, well, let's start with one angle. What is equal to this angle? I know the one across from it is equal. And I know the corresponding ones, the ones in the same spot are equal. And that across is equal. This one's not equal.
This slim.
So we're adding them together and setting them equal to 180. They're not the same. These, if you're just curious, I'll give you the names if you're curious. These are called same side interior angles. You don't have to know it though.
But then you might hear a random, but you might not love it, so you like, yeah, that's great.
Okay, let's see. Number 13. Are they equal or will I add them up? Add them up. Why? Because they're side by side. They form a straight line or that half circle shape that we see. Just like that. So we're going to add these to 180 degrees. Perfect. How about number 14? Now this one's tricky because the angles look the same. Equal. Yes. They're like vertical angles, but then one down, corresponding vertical in a way. These are equal to each other. If we want to think about it like this, here's this one, right? Its vertical angle is equal, and that corresponding angle is equal. So these are equal. So we set them equal. Opposite exterior angles. What those are called. Okay. How about 15? Equal. You guys are getting quicker. Equal. They're the same size. It's the big ones.
I think of it as a C. You see a C.
Yeah. That's a good way to think of it too. If they're making that Z, they're on the opposite sides. It's gonna be equal. How about 16? Equal. What's the relationship called when they're right across?
And corresponding.
Corresponding is when they're on the same side.
Vertical.
Vertical is when they're right across.
I have a random question.
Yes.
Why do some of them have two red triangles and other ones have one red triangle?
Great question. I have
Okay.
no idea.
All right. Make sure.
I don't know. Maybe some of them just want to be different. Couldn't tell you. I'm kind of curious about it.
I know. I'm like, wait.
Okay. 17. Another tricky one because they look really similar. Are they equal or do we add them up?
The same one.
Add them up. They're right beside each other.
Side by side.
Add to 180.
So,
They're not equal. Add to 180 degrees. So maybe I should put that in like a different color. We can look at all the related. If it helps, seriously, draw all of the angles. Use colors if you need to. There's the orange one. There's the purple ones. They're not the same. How about 18?
Equal.
Equal. What are those called?
Vertical.
Vertical. Good. They'll be equal. About 19. Equal. What are they called?
Corresponding.
Almost
Vertical.
vertical. I'll go back, Lisa. 18 was also equal and vertical.
Yeah.
Yeah. Let me. That's what I was waiting for right there. Here we go. Vertical. It's vertical,
yeah, that's how they talk.
so they're equal. What about 20? Equal, what are they? Vertical, good. Good, good, good. Your repetition is the key. Just gotta do it over and over until your brain understands it. Okay, so we've gone through, we have identified whether they're equal or whether we need to add them up and set them equal to 180. Now that we have that information, you think you can solve some of these? I think you can. Actually, I don't just think it, I know that you can because we've just done so many of these and I feel like you guys can do it. So here's what I want. And this will be your exit ticket today.
Okay.
This will be your exit ticket. Nope, not all of these. Your exit ticket is going to be number 7 and number 8 on this worksheet. Yes, number 7 and number 8 on this worksheet. If you are wanting to keep this worksheet, I'm going to make a different copy. I'm going to draw these out on a separate piece of paper and create an actual exit ticket. You're welcome to wait for that. And then I'll make copies for those of you that don't want your exit ticket on the worksheet because it's kind of messy. So number 7 and number 8 will be your exit ticket today. Let me put those on a separate paper. I'll leave it up. And draw that out for them. And this is the last thing I will assign you for this week. That's it. And it is only 11:05. We do technically still have 50 whole minutes of class left. That being said, if you want to have me check it before you go, so that if you have corrections to make, that way you don't have to come in tomorrow if you don't need to. I'm happy to check it for you. I answered yeah real quick. I have not worked it out myself yet. You're good to go. All right. That's kind of drawing this. Oh. Yeah. Yeah, I know. But
Yeah.
there we